Hello everyone, I hope you all are fine there and you are studying well. So in today's Trickopedia session, we will discuss about the tricks for inductor, okay? And it will help you in power electronics wherever inductor is there in the load. Now you can see that in inductor, we have this inductor and this is VLT, voltage across inductor, this is current. We know that VLT is equal to LdI by dt, and from this equation, if you calculate current, if you find current, then this is the current equation. Let's say the current waveform is given to us. Now from the current waveform you can directly understand some points, directly tell about some specific points. And what are those points? You can see that at this point A, B and C, at these 3 points the level of the current is same. Wherever the level of the current is same, let's say from A to B, the level of the current is same. It means up to this point, VLT, and if you calculate the area from A to B, that will be 0. Okay, the area will be 0 between A and B. Which area? Area of this voltage VLT. Okay, so remember this point. Similarly, it's not about B only. It's about B and C or A and C. Similarly, you can see that D and E, they are at the same level. So if you draw the waveform of voltage and if you calculate the area of the voltage wave from D to E, it will give you 0 answer. So remember this point. This is very interesting trick. The next point is, at these points, you know that the current has the maximum or minimum. At these points, the current has maximum at 1, B, 2, at this point. So current has maxima or minimum. Wherever the current has maxima or minima, at that point, di by dt will be 0 and VLT will also get 0 value. You will get 0 value. It means if you draw the voltage wave shape, you will get 0 value of the voltage at these instants. At these instants, at A1 point, B, 2, this point and 3. At all these points you will get 0 value of VLT. Now there is one more interesting point. If you are going from A to 1, you can see that the current is rising. If current is rising, di by dt is positive. So from this A to 1, VLT will be positive. So up to this point, between this range, in this range, VLT is positive. From 1 to B, VLT is negative. From B to 2, again VLT is positive. Okay, between this range you are getting positive. Now you can see that if one wave is positive in this zone and negative in this zone, obviously it has to change its sign. It means at this point it has to be 0. At this point VLT has to be 0. Similarly, before this point it is negative, after this point it is positive. So at this point it has to be 0. Okay. So these are the information that you can trace out from the current shape. From this current wave shape, you can comment on the voltage wave shape without drawing the voltage wave shape. Okay. I hope these tricks will help you to draw the wave shape across inductor, especially when the current wave shape is provided to you, and if you want to draw the voltage wave shape. So without any mathematics, you can understand like this. This type of video you will get in upcoming sessions also, and I will record some more videos on Trickopedia, specifically on power electronics, network control, and I hope you like it. I hope you will take advantage of this trick in power electronics and in network as well. Okay, so thank you for watching this session. Do subscribe our channel and please like this session. See you in the next video. Thank you.